Hello everyone, welcome back to my YouTube channel. Myself Monisha, studying in Shri Venkateswara College of Engineering from the Department of Information Science. Today's topic is Hadoop monitoring and logging. So, moving towards introduction to Hadoop monitoring and logging. Hadoop monitoring and logging is essential for ensuring the smooth functioning and performance optimization of Hadoop ecosystems. Monitoring helps in understanding cluster health, resource utilization, and identify potential bottlenecks. Logging provides a detailed record of events, errors, and warnings, aiding in troubleshooting and auditing. Hadoop is an open source Java based framework that is used to share and process big data, an innovative project that opened up big data horizons for many business. Hadoop can store a terabytes of data inexpensively on community servers that run as clusters. There are also good cloud options with Hadoop if distributed file system is designed to enable the greater fault tolerance and concurrent processing. This increase in tolerance and processing speed enables larger quantities of data to be processed more quickly, improving the timeliness of data insights and the level of in-detailed analysis possible. As you can see in the above diagram, the Hadoop is being generated. The benefits of Hadoop monitoring and logging. The first one is speed. Fast storage and data retrieval. Hadoop allows parallel processing across a dataset. With tasks split and run concurrently across distributed servers, Hadoop framework allows for dramatically improved processing speed over prior types of data analysis, whether on local servers or in the cloud. Second one is fault tolerance. Replication allows for resilience because data stored in any particular node is also replicated elsewhere in the cluster. Hadoop has a high level of fault tolerance to handle one node going down or some type of corrupted data. Hadoop also helps to keep data secure and constantly accessible. Third one is scalability and capacity. Larger volumes of data with a quick growth. The Hadoop Distributed File System (HDFS) allows data to be sped up and stored across the commodity servers clusters with simple hardware configurations. Cloud installations of Hadoop are also especially well suited to its distributed file system. Cost savings. Open source accessible software. Hadoop is an open source framework, which means anyone with a programming language and storage space can create a Hadoop system. No license is necessary to allow more staff to access Hadoop. For local hardware, community servers helps to keep the system economical, while cloud storage space is now widely available at the economical prices. Managing diverse data, many formats, many uses, the Hadoop file system can store a wide variety of data formats in its lakes, including unstructured data such as videos, semi-structured data such as XML files, or structured data such as the contained in SQL databases. Data accessed through Hadoop is not validated against a schema, so it can be passed to fit into any schema. Why is Hadoop important for big data? Hadoop is in many ways the foundation for the modern cloud data lake. With its open source nature, it is democratized big data and mass computing power. Companies were able to change their approaches to digital marketing and embrace the big data analysis due to the scalable economical options provided by Hadoop. Before Hadoop attempts at big data analysis outside the largest search engine, enterprises largely depended on proprietary data warehouse options. Hadoop created the pathway to much of the current developments that have been continued to advance big data innovation. Indeed, companies tend to use big data infrastructure that relies on Hadoop or its underlying distributed file system, even if they do not use of all of its components. Hadoop is continuing to innovate, opening up new processing mechanisms relying on its file system. Monitoring tools for Hadoop, distributed storage and distributed processing of large data sets have always been a challenge for IT admins. This increasing need to store and process large data sets efficiently led to the development of the Hadoop framework. With its massive storage capacity and enormous processing power, Hadoop allows users to manage ever increasing data sets and perform tasks easily. However, it is important to ensure the smooth functioning of the Hadoop framework. With Applications Manager Hadoop monitoring, it's easy to get operational insight about your distributed storage environment, connect to Hadoop clusters via the REST API or JMX, maintain optimal health of the distributed Hadoop cluster, and ensure that your clusters are available and processing tasks quickly and accurately. Apache Ambari provides a comprehensive monitoring and management platform for Hadoop cluster with a user-friendly web interface. Cloud Manager offers centralized monitoring, altering, and diagnostic capabilities for cloud-based Hadoop distributions. Ganglia, a scalable and distributed monitoring system that collects and visualizes cluster metrics in real time. Log aggregation and analysis. Log aggregation is the process of collecting, standardizing, and consolidating log data from across an IT environment in order to facilitate streamlined log analysis. Without log aggregation, developers will have to manually organize, prepare, and search through log data from numerous sources in order to extract useful information from it. In this article, we will discuss how log aggregation works, why it's important, and what you should consider when choosing a log aggregation solution. Logs include a wealth of information that can help developers monitor activity and troubleshoot issues within their system. But they must be systematically collected and standardized in order to provide the most value. Log aggregation is one of the early stages in the log management process and it can be accomplished through several different methods. First one is file replication. Log, log files can be copied to a central location using tools like resync or cron. While these commands can relocate log files, they do not support real-time monitoring. Second one is syslog. Logs can be directed to a central location using a syslog daemon, also known as a log shipper, which can work with various syslog message formats. This relatively simple method of aggregation logs, but it can also be difficult to scale. Automated pipelines, log processing pipelines incorporate syslog daemons or agents to systematically ship, parse, and index logs on a continuous basis. Some pipeline tools are also coupled with additional log management features such as analysis or alerting. Alerts and notification. Setting up alerts for critical matrices helps in proactive monitoring and prompt response to potential issues. Email notification, SMS alerts, or integration with popular incident management tools like PagerDuty ensure timely actions. Automated actions triggered by the alert, such as scaling resources or restarting failed services, aid in maintaining the cluster health. Best practices for Hadoop monitoring and logging. Hadoop is a popular framework for parallel programming that enables distributed processing of large data sets across the clusters of computer. However, working with Hadoop can also pose some challenges and risks, such as data loss, corruption, inconsistency, or performance degradation. Therefore, it is essential to follow some best practices for error handling and logging in Hadoop, which can help you avoid, detect, and resolve problems in your applications. In this article, we will discuss some of these best practices and how they can improve your Hadoop experience. Use fault tolerance features. Hadoop provides several features that enhance the fault tolerance of your application, such as replication checksums, speculative execution, and recovery mechanism. Validate and sanitize input data. Another best practice for error handling and logging in Hadoop is to validate and sanitize your input data best before processing it. In input data can some various sources such as files, databases, streams, or user inputs and may contain errors, inconsistencies. Handle exceptions and failure gracefully. Even with fault tolerance features and input validation, you may still encounter exceptions and failures in your Hadoop application. This can be caused by various factors such as network issue, hardware failures, software bugs, or unexpected input data. Use proper logging levels and formats. Logging is a vital tool for error handling, and logging in Hadoop as it helps your computer analyze your applications. However, logging can also have some drawbacks such as consuming disk space, bandwidth, or memory, or affecting performance or security. Challenges and future trends. Despite its many limitations, Hadoop will not be replaced entirely by cloud data platforms because it's been around for so long. Hadoop has become a solution business have learned to trust. The way it works is familiar and its limitations are known. That's why common some business are hesitant to let go of Hadoop completely. With it, they know what to expect. The familiarity of a tool can be especially significant when dealing with something as sensitive as data. Hadoop is the preferred solution of large organizations, while cloud data platforms might be better suited to a wide range of business. That's why certain companies will continue to choose one or the other based on their needs and preferences. The hybrid model is more reactive than Hadoop alone and provides real-time prediction. If a company has a lot of data and Hadoop, it will be difficult to migrate it out all the cloud. That's why this model can meet the needs of companies that already have Hadoop but want to try a more modern solution. There's also a money-saving option for companies that want you to use a cloud data platform but have enormous amounts of data, as storing all the data on the cloud alone is expensive. It will be less and less visible, but it will remain a solution companies rely on. Conclusion for today's topic is Hadoop monitoring and logging are crucial for optimal performance, troubleshooting, and ensuring the availability of Hadoop clusters. By implementing robust monitoring tools, logging infrastructure, and best practices, organizations can effectively manage and optimize their Hadoop system. Continuous innovation and evolving technologies will shape the future of Hadoop monitoring and logging, enabling smarter analytics and improved operational efficiency. Thank you.